Hi guys, welcome to my channel. So in this tutorial, we'll be looking at the integral from 0 to infinity of x, natural log of x divided by x to the fourth plus 1 dx. So if you haven't subscribed to my channel yet, make sure you hit the subscribe button and hit the notification bell so that I'll continue uploading more engaging and challenging integrals. So let's look at this integral. So let's try to rewrite this. This one, let's try to divide the numerator and the denominator by x squared. Do the same thing to the denominator, dx. This one rearranges to integral from 0 to infinity of natural log of x over x divided by x squared plus 1 over x. That is dividing x to the fourth plus 1 with x squared dx. So let's do some rearrange. So that is natural log of x divided by x squared plus 1 over x squared times 1 over x dx. So let's do a u-sub here now. We are going to do a u-sub. That is equals to, we can let u to be equal to the natural logarithm of x. So that implies that x is equals to e to the u. So wherever we see x, we can plug in e to the u. Wherever we see natural log of x, we can plug in u. So let's take the derivative. Du dx is equals to 1 over x. That implies du is equals to 1 over x dx. So it means wherever I see 1 over x dx, I can replace that with du. What about the change in limits? When x is equal to 0, what happens to u? U is going to be the natural logarithm of 0. That is equal to negative infinity. What about when x is equal to positive infinity? U is going to be the natural logarithm of positive infinity, which is positive infinity. So u runs from negative infinity to positive infinity. So let's take our integral from the x world into the u world. So our integral, the integral now becomes integral from negative infinity to positive infinity of natural log of x. Natural log of x is u divided by x squared. But we know that x is e to the u. So that is going to be e to the u squared plus 1 over x squared. That is 1 over e to the u squared times 1 over x dx. 1 over x dx is du. That is du. So you can have integral from negative infinity to positive infinity of u all over e to the, you can multiply this one out. This is 2u plus 1 over e to the 2u du. This simplifies to integral from negative infinity to positive infinity of of u all over e to the 2u plus e to the negative 2u du. So how can you evaluate this integral now? Integral of u divided by e to the 2u plus e to the negative 2u. With this one, whenever we have an integral from negative a to positive a of f of x, this is always equal to 0 when f of x is an odd function. So we have integral from negative a to positive a of f of x. That is always equal to 0 if you are able to establish that the function f of x is an odd function. How do you determine if a function is an odd function? F of x can only be an odd function if the f of negative x is going to be equal to negative of f of x. So if you're able to establish this, then you have proven that the function f of x is an odd function. So if you're able to prove that this one is an odd function, then our integral is equal to 0. Because right now it is very challenging to find an integral of u divided by e to the 2u plus e to the negative 2u. So we may have to establish that u over e to the 2u plus e to the negative 2u is an odd function. If we're able to establish that, then this integral will be equal to 0. So our task now is to find out whether u over e to the 2u plus e to the negative 2u is an odd function. So we want to establish that the function f of u, which is u over e to the 2u plus e to the negative 2u, is an odd function. Is odd or even? Let's find out. So it can only be an odd function if f of negative u is equal to negative f of u. So let's find f of negative u. F of negative u is going to be wherever you see u, you plug in negative u. So that becomes negative u divided by e to the 2 of negative u plus e to the negative 2 negative u. Wherever you see u, you plug in negative u. That becomes negative u divided by e to the negative 2u plus e to the 2u. That is negative 2 times negative u. That is 2u. And that is equal to negative u all over e to the 2u plus e to the negative 2u. So it means f of negative u is going to be negative u over e to the 2u plus e to the negative 2u. And what is this? That one is f of u. So that is equal to negative f of u. So we are able to establish that f of negative u is equal to negative f of u. So in that case, our function f of u is an odd function. So that is how we establish whether a function is odd or even. So now that we have established that our function f of u is an odd function, that means the integral from negative infinity to positive infinity of the odd function is just going to be 0. So we have the integral from negative infinity to positive infinity of u all over e to the 2u plus e to the negative 2u du. This is equal to 0 since f of u, which is equal to u over e to the 2u plus e to the negative 2u is an odd function. So by extension, that implies that our integral from 0 to infinity of x, natural log of x all over x to the 4th plus 1 dx is equal to 0. So this is the value of our integral. So that is how you evaluate this integral. So if you find this video helpful, make sure to smash subscribe button for more content. Thank you so much for watching the video, and I will see you in the next one. Bye bye.